Okay, so we're upping the ante for this lesson, lesson 6 of our first unit, second last one. So we've been looking at transformations of trig functions. We've been looking at them individually for the most part. And so now we're going to be practicing with multiple, and specifically all of them as we move across the screen. So remembering that, and if you need to label it to remind yourself, that's completely up to you, that A is talking about amplitude and B is your horizontal stretch or compression, and that impacts your period. C is your phase shift. Again, that's horizontal. And D is your vertical shift. Okay. Another thing to maybe remind yourself of is that these kind of have opposite impacts. So when we get a bigger value for B, it actually is a compression. If we get a smaller value for B, it's a stretch. So those are some things to kind of bear in mind. Also, when we have a phase shift, the sign in the equation is opposite the direction because in our general format, it's supposed to be subtracting the C value. So just a couple quick reminders before we look at this. So if we are completing this chart, period for this one will be affected. So again, period is equal to 2 pi over B. So 2 pi divided, I'll just write that over here. So that's going to be 2 pi divided by 2 in this case. So that's pi. My amplitude is looking right here, A value. That's missing, so it's implied that it's 1. The domain, it still can go left and right forever, so that's negative infinity to positive infinity, and don't forget your round brackets. My range, there's no vertical stretch or compression, my amplitude's still 1. There's no shift vertically, so my midline's still at 0. Both of those things combine to look at my range, so I'm going to go from -1 to +1, just like my parent function of sine x. My phase shift, I'm not moving left or right, I'm missing a C value, so that's non-existent. And zeros, well, if we need to kind of sketch it to remind ourselves, I always just draw a quick one, just as a reference. It doesn't need to be beautiful. Yeah, that'll do. So sine is at 0, pi, and 2 pi. Or we can just say k pi, where k is an element of the integers. All right. Oh, except sorry, we've horizontally compressed it, so it's k pi over 2, because again we've divided by 2 for our period, so we've divided by 2 for those. Okay. So next one. Now we're affecting both our period and our amplitude. We're going to go 2 pi over 2, because B is equal to 2 here. We've also got an A value, so again, this is going to be pi. My amplitude is half of its original amplitude. So horizontally, that means nothing, negative to positive infinity. But my range then becomes smaller because I haven't gone up vertically. But I'm not going to be getting to a maximum at the same height. My maximum is half of its original. So instead of going to 1 and -1, I'm only going to go to -1/2 and +1/2. So in general, your range, you're going to look at a plus or A minus D and A plus D as your kind of descriptors. Domain seems to be pretty consistent. Amplitude is just your A value. Phase shift is C. And your zeros for sine are going to be K pi divided by B, just like we did for the first one. Because originally it was K pi without any sort of compression, but instead of being at pi and 2 pi, my period's half of that. So this is pi over 2 and just pi. That's where all this came from. Okay, so bearing that in mind, haven't had a phase shift yet because I'm not subtracting from x in the brackets, and my zeros should be the same because my period is the same as the previous one. Now, here is where things get really complicated. So my B value is still the same. Okay, so my A value is still the same as the previous one. Now my C value is pi over 4. And again, I leave out that negative. So B value is still the same, so it's still pi. A value is still the same, it's a half. Domain hasn't changed because I'm still working with the sine function. Range, I haven't had a vertical shift, so it's just my amplitude that's changed. And so we've got those two pieces. So we've got negative a half. I'm going to rewrite this so it's a little bit more legible. It's negative A minus D and positive A plus D. So negative a half and positive a half. My phase shift is now pi over 4 positive, which means that instead of looking like this, I'm going to sketch it out for myself. My curve was actually going to start here at pi over 4. So whereas my first two graphs, it was 0, pi over 2. Well, what's pi over 2 moved over an additional pi over 4? Well, that's going to be 3 pi over 4. And instead of pi, it'll be 5 pi over 4. Okay, so that shift. So when I go to talk about zeros, I'm going to talk about 3 pi over 4 and 5 pi over 4. You're fine, but otherwise k pi plus pi over 4. Yeah, do that. Okay. Our last one, we've got all three. So now we've got A, B, C, and D. And whereas for C we ignored the sign because that was its kind of original part in the equation. We have that negative showing up in here already, so we just care about the value. D is supposed to be positive, so if we see a negative sign, it needs to be attached to our value for a vertical shift. So with that in mind, period stays the same, still B equals 2. Amplitude still stays the same. Domain stays the same. Okay, but we get into some wonky range here. You know what, I don't have an idea. Lose that, and we'll just talk about that sketch. So that vertical shift of down 3 means my midline is now here. What you're really trying to do, and that's really where I was going with this guy, is it's our D value minus our A value and our D value plus our A value. That's what I was trying to do before. Sorry about that. Okay, so here we're going to go, we're shifted over, we're down here, and we're going to go only a half up and down. So my range is going to be maxing out at -2.5 and bottoming out at -3.5. Okay, and so minimum's always first, maximum's always second. Okay. My shift is still the same. My zeros now no longer exist. Because of the shift downward. I've taken my graph so far below that x-axis that I'm never going to get there. And we see that in our range because 0 is not between our minimum and maximum. So that might seem overwhelming, but I promise the more you do, the more comfortable you get. In general, these are the steps to follow. So you kind of want to backfill, sketch your main curve, then work from there. You account for your B value first and calculate your new interval and label your x-axis based on that. Use your A and D values to label your y-axis, then account for your C value in terms of like where you actually place your curve. So for example 2, what we're going to do is we're going to actually start to try and graph. So we're using these steps, and this is from the previous page, I just kind of stole it. So you want to draw the main curve, account for your B, account for your A and D, and then account for your C. And that important part is really that you truly need to decide what your x-axis and y-axis scales are going to be. So another kind of set of steps that I use instead of these. So this is one that I've stolen from someone else, and it will 100% work. But what I'm going to show you is a different set of steps. And the key thing is to start by identifying just what your A, B, C, and D values are. So A, B, C, and D. So A is 2, B is 2, C is -π/2. Again, remembering that the general form has a subtraction sign there, so 2 negatives make a positive, and D value is -1. So why is it really important that we look at these numbers? Well, our B value tells us our period. So that means that our period automatically is 2π divided by 2, or just pi, which we saw on the previous page, so that's why I'm not going to show my work. I know that my midline is going to be at -1 instead of at 0, which means that my range is going to be from -1 up to and down to. So for down to would be to -3, and up to would be to +1. So with all of this information, that helps me really decide how I'm going to break it down. Also, knowing my C value tells me that pretty much like how I want to split up my x-axis, because I want to be able to show that I've shifted over π/2. So when I draw my graph and I start putting in my axes, I'm going to show -π/2, and I'm going to show that I'm accounting for these different changes. And you know what, I probably am going to spread it out more. So this is where deciding on this before you draw your curve, and why I don't really necessarily like that step 1 being your curve drawing. The only thing I would maybe recommend is sketch your parent curve just so you have a point of reference. So sine looks like this one up on the top left. Okay, so I definitely want to have that π/2 labeled, but I also know that I only need to go from π/2 to pi. So I can play around with like what my scale is here quite a lot. So I don't need this to be -π/2 and π/2 because that's going to really squish my graph. But I can say put it even over as far as like 4 over here. Say this is -π/2. And so then this would be pi over 2 here. And that's my period that I'm going to be working with. Vertically, again, my midline's at -1. So I want to be, and I need to be able to get down to -3. So I'm going to make sure that my minimum is at least -3. And then I'm going to go up from there and try and subdivide it evenly. So maybe a little bit better. Like that. Okay, and then again up here, I'm going to try and match that subdivision so that I can go up to +1. And there we go. So we see this and it looks great. So what we're going to do is my starting point then is at -pi/2 and -1. I'm going to do it in blue just so it shows up over top of my other writing. Again, you might want to draw in your midline if that's something that helps you, just to think about that shape fitting onto here. And then my full period has to happen by pi/2 because that's exactly pi, which is my period. So if you want to think about it as like, even if you're looking at your unit circle, going from pi/2, 1 pi would be to positive pi/2. So something to think about. You can always refer back to that unit circle diagram. And so that means that halfway between the two is where my other 0 is. This one belongs here. Okay, and then I should be going up and then down. So again, halfway between them is going to be my maximum, which I've established is 1, and that's over here. And then halfway here is going to be my minimum at -3. So that's how I'm applying those transformations. So I'm going to go up and down. Now I could have continued on, so I could have another maximum here, another 0 here, another minimum here. It's completely up to you how far you want to draw it. And I mean, part of that is also controlled by your scale. The key thing is to make sure we put those arrows on the end to show that our graph is continuing, and don't show that this is going down because that's not true. Make sure you're curving it back up. So that's kind of the key idea to drawing this. So I hope that that makes a little bit of sense, and you can try the next example here. If you want to pause this and give it a shot for yourself, I think that would be a really good idea. All right, so I hope you were able to get this part done. Again, labeling your A, B, C, D is very, very helpful as a point to kind of go from. It also helps you figure out your period, which determines your x-axis. Your C value also helps determine the further breakdown of your x-axis. And then by using your D and A values, you're able to figure out your maximum, minimum, and that will tell you your y-axis. Once you've done that, again, that starting point, quote unquote starting point, is going to be determined by these two pieces here. And again, we're dealing with sine. So my parent function, if you need it sketched out in here, if you like having it as a reference, you can do it right on your graph. That's not really my jam. I usually do that sketch on the side just to remind myself of all those key points and general shape. But if you want to do it right on your graph, you totally can. So my parent graph would look like this. So I would just label that as f of x equals sine x so that I know it's not that graph I'm actually wanting to draw in the end. Once I've done that, that helps me figure out, okay, so starting point is positive pi/2 plus 1 goes here. Then I've got from there, instead of going to just pi/2, I'm supposed to be stretching it to pi/4, but it's pi/4 plus pi/2 because of that phase shift again. So that's there. Halfway between those, that should have been pi/2, but again, shifted over. But pi/2 is here. And then I can find my halfway points from there, so it should be, it originally would have been pi and shifted over, and my maximum's at 4. My minimum should have been at 3 pi, but shifted over is here, and -2. And there we go. That's a little high. I have not perfected my sine curve drawing on this surface, so I apologize in advance. I'm not going to extend it to a second set of curves, or a second set of period, just because I'm already running out of room, but you totally could. But that's how we would go about sketching this. So you can pause again and try this one yourself. My only point here would be watch out, because it is cosine instead, which means that your OG starting point should be at 0 and 1, not 0 and 0 like for sine. So give it a pause, give it a shot. So if you're stuck at this point, again, identify A, B, C, D, and then calculate your period, which in this case is 2 pi over 3, so that's going to be an awkward one. With my horizontal shift, something that I might even consider thinking about doing personally is just thinking about it as 4 pi over 6, just so that I can work with the same denominator, because the more denominators we start throwing in there, the more confusing it gets. Vertically, figure out my max and min to decide my y scale as well. So again, give it a pause with that information, see if you can draw it. So you'll notice that I'm obviously very zoomed in because my scale is so tiny on that y-axis. If you aren't following along with this whole idea of like, where do I put things, and that idea of using these A, B, C, and D values for transformations, you can always make a table of values. There is nothing stopping you from doing that. And so I strongly encourage you that if this isn't making any sort of sense, then please use a table of values. So those are some practice questions or practice examples. We can also work backwards, and that's something you'll see frequently on the provincial exam as well, is you'll see them give you an equation or a graph and ask you to write an equation. Remember that both sine and cos look very much the same, and so you can always choose a sine function or a cos function. So I'll do both for this first one. But before I do anything, I can still identify my A value, which is, it would appear to be half, whole, half, whole. I would say A is 2. I would say that my midline is, so D is 2 because it's been moved up. Okay, and that my period, instead of being anything else, like any like pi values, is 12. Okay, and so given that, we can calculate B is, sorry, not D, B is 2 pi divided by 12, or pi over 6. That doesn't, yeah, that does make sense. So it seems really weird. I entirely agree, but that's going to be my B value. Then it's just a matter of deciding on C, and that's entirely dependent on whether it's a sine or a cosine function. So with sine, we know that sine starts at 0. And so does this graph. It starts right at its midline. So I'm not going to actually have any sort of value for C in this case. So I would just say 2 sine x, because that's my horizontal value. But don't forget your B, so pi over 6x, and you can put brackets to help you remember, and then plus 2, because that's my D value. Now if I wanted to write this as a function of C, or cosine, sorry, getting ahead of myself. Then what I would need to consider is that cosine usually starts at a maximum. And so instead of starting at 0 and a maximum, it's moved over to approximately what I would say is 3. So I would say that my C value for cosine, whereas C was here, C is here, and so that's going to be negative or positive. 3 is my shift. Remember, it's always the opposite sign when we plug it into the equation. So I'm going to use my A value. My B value is pi over 6. And then I go x minus 3. And then plus my D value. Now please note that it's really, really important that that B value is outside the brackets and C value is inside these brackets, but we have another set including all of it so that both the B and C value are impacting our X and not our Y value. In terms of why this happens, it's because both B and C impact X on our graph, and so we want to show that in our equation as well. And if we don't include those brackets, then things start to get confusing, because is it cosine of pi over 6 and then multiplied by x minus 3 or what? So I like using both sets of brackets, and this is appropriate notation. If you ever see something written like pi over 6 x minus, in this case it would be pi over 2, if this was distributed through here. That's not appropriate notation. You'd be able to determine your B value from it still, but you would not know your C value, because that would be incorrect. And that doesn't match what we see on our graph here. So just a heads up. Continuing to the next examples, we're going to do the same thing. So if you want to pause after we identify the A, B, C, and D on this graph, so that you can practice plugging it in, and then the next example you can try entirely on your own. So give it a pause right now, or after we determine the A, B, and C value. So A, in this case, again, we're always looking at our maximum. A is, and I'm just going to write it on the graph, it's going to be, it's not shown very well, but I would estimate that that would be approximately 5. And then I would say that my midline, based on the fact that the bottom seems like it's probably negative 3, that's a difference of 8. So my midline actually would be right here still, at positive 1. And how you can figure that out if you're not sure is you take your maximum and subtract your minimum, divide by 2, and that's going to give you your D value. Okay, so that's a handy little hint to use. But otherwise, you can just look and figure out what's halfway between your minimum and your maximum, whichever one makes the most sense for you. So D in this case is going to be plus 1, because that's where my midline is now. Horizontally, I look and I have my period repeating at pi, which means that my B value, if my period is pi, then B is 2 pi divided by pi, or just 2. Okay, and we've seen that a lot in the previous examples working backwards. So finally, again, it comes down to deciding my C value, and that's always going to be the last thing you want to choose. So if I'm, again, working with sine starts at 0 and 0. So we're seeing that same impact here. We're seeing that same shape of that, but just moved up. So I'm going to leave C as equaling 0 for this case, and I'm just going to have 5. B is 2x is my variable from the horizontal, and plus 1. If we're doing cosine, again, cosine starts at a maximum, kind of looks like that. So I'm going to be looking at starting here instead. So I could say something along the lines of 5. My B value is 2x, Again, it's shifted to the right, so it's going to be subtracting, and I'm going to say 0.25 pi. I'm going to use the same language that's actually in my example. I'm not going to try and convert it to a fraction. So minus 0.25 pi, and then plus 1. So those are both options. If you want to pause for this example, and even pause for the next two, we're going to assume for D that this is supposed to be 1 and 1. Okay, negative 1. Sorry, those aren't labeled. So we'll assume for both of them that they're drawn appropriately. Give it a shot. Give these a try. Okay, so just a couple quick things. As I was doing this example, I realized I made a very glaring error here that hopefully you caught, and you were just questioning me at home, being like, Miss Conrad, why is that the way it is? So when we're tackling these, we really do want to figure out the amplitude from the midline. So in our first example, it was drawn in, so I did it automatically. But that amplitude is always from the midline. So you want to find your maximum at 5, our minimum at -3. We found our halfway point was +1, and that's where we find our A value from, which would be, in this case, 4, not 5. So that was a big glaring error I made. I did better here. These should be the answers that you got for this particular graph. So again, 2 shows up again. One thing that you can do, so you may have actually written y equals 3 sine of 2x minus 0.5x, or pi. Sorry, I don't know why I keep doing that. I did it here too. You may have done that, and that's totally fine. But another option is that remember that negative, and we saw this show up a little bit when we were doing our explorations, flips my graph over my x-axis. So I can implement that negative comes into play. And now instead of expecting my sine graph, if it was just negative sine x, I would expect it to look like this, which is what I'm seeing here. So that's why I implemented that instead of going with a positive and a horizontal shift. Both are entirely correct. Typically, you're not going to have restrictions as to which one would be correct and which one wouldn't be. Those would both be acceptable answers on the provincial. So again, pause your video and try this one. A really awkward B value, but that's totally okay. Based on the scale that we were given here. I hope that both of those answers make sense to you. If you did a reflection, you could have said that it was, for example, for cosine, you could have also said that y equals -3 cos of 2 pi over 9. And then it would have been x plus 1 plus 3. And that would account for flipping it over, so starting at a minimum and shifting it left. So all of those are perfectly viable answers. It's just whatever you're kind of predisposed to. I try and minimize things as much as possible. So in the previous example, we saw that adding that negative meant I avoided this entire back end piece. So that was my motivation there. And since it didn't change anything else about my equation, I didn't see the point in including that reflection. But that's your call. And I think that's our last example. So I'm going to post some practice questions for you, and you can give them a shot. And there is an assignment posted on Quest that includes stuff from this lesson and the next one. So you are more than welcome to take a look at those questions and try ones that you feel adept to try.